Welcome everyone to another Leetcode problem. Today's problem is problem 300, longest increasing subsequence. And this is one of the problems in blind 75 list. So the problem description says we are given an integer array. Okay. We have to return the length of the longest strictly increasing subsequence. Okay. So by strictly increasing subsequence means any sequence that is strictly increasing. That means two values are not even equal. For example, here you see that the given input for the first example, this is the given input, and then we have to find the longest strictly increasing subsequence. Now, if you look carefully, you see that 7, 18, this is this increasing subsequence. Also say 2, 3, and then 18, that is also an increasing subsequence of length 3. Then 10, 101, this is an increasing subsequence of size of length 2. But the longest one is 2, 5, okay, not 2, 5. So, or we can say 2, 5, 7, 18. You can see this is a subsequence of length 4, and this is an increasing subsequence, right? Similarly, it can be 2, 3, 7, and 101. That is also of length 4. So in any case, the highest length subsequence, that is increasing subsequence, is of length 4. That's the answer here. For the second example, you see for the second example, this is the input, right? And let's find the increasing subsequence. Well, so what about 0, 1, and then 2, and then 3, right? So this is an increasing subsequence of length 4. Or if I do like this, 0, 3, and then I cannot go anywhere. So this is subsequence of length 2. So anyways, the output here is highest length is 4. For the third example, you see here that all of these are the same values. So there is no increasing sequence can be made out of it. So everything is by itself. So 1, right? Okay, so every number creates its own sequence of size 1 and it doesn't increase from there. Okay, so how do I solve this problem? Well, let's think about the most naive way to do it. Well, the most naive way to do it is, what about creating all subsets, right, of the input? Say one subset is say 9, then 2, and then 5. This is one subset, right? And let's see if this is increasing. This is not increasing, so this is a failure, right? Similarly, let's try with another subset. Let's say 2, 3, and then 18, right? This is another subset, and we check it and we see that this is increasing, right? Okay, so then we save this value somewhere 3, right? So we create all subsets. One such subset is going to be 2, 5, 7, 18, right? So this is another subset, and we keep on checking and see this is an increasing subset of size 4. So previously we had found something of size 3. Now we have size 4. Then we save it somewhere and put it as 4. So we can actually keep on doing this. And for each subset, we can just check like if it's increasing sequence, and if it's an increasing sequence, what is the length of it, and if this length is greater than the previous biggest largest length, right? But what is the time complexity of this algorithm? Well, this is going to be like crazy, because we know that there are like, if there are like n elements here, then there are 2 to the power n subsets, and for each of the subsets I'm checking, right? So it's order of n thing here. So overall it's going to be order of, so I'm checking for each of these subsets, so it's going to be n into 2 to the power n. So this is a horrible algorithm, right? Okay, so let's think about how we can do it more efficiently. Well, we can do it more efficiently using dynamic programming, specifically saying we are going to use bottom-up dynamic programming. Okay, so bottom-up approach. or tabulation approach. Okay, so let's start from the rear. So this is say an input, and let's try to find, this was from example 1. Okay, so initially what we can say is, like, we can keep an array, right? dp, and this is for each of these values represents this increasing subsequence starting from that index, right? Okay, so this is going to be index 0, this is 1, 2, 3, 4, 5, 6, 7. Okay. Okay, so what I do is, initially I initialize it with 1. Okay, because we know that every element creates a subsequence of itself, a sequence of itself of length 1. Okay, now we start from the end. So we start from the end. This is my first pointer, right? And what it does is, uh, okay, so we can start from the end, or we can start from, okay, so let's do this. So this is my first pointer, and my second pointer is actually from the starting point, it goes all the way to the end. Now for this case, you can see that uh, all the way to the end, this is already the end, so I don't need to go further. So I don't have anything to compare, then I'm done. Okay, now my next pointer is here, and my second pointer now starts reading from the next pointer up to the end, right? And first one, you see that 101 is greater than 18. So that means uh, there is no chance that it can create another sequence. So I don't have anything to change. Next, I move my pointer to this, to 7, right? Now I start reading the values from everything from the next element up to the end. And as you can see, 7 is smaller than 101. Also 7 is smaller than 18, right? Okay, so that means it can create increasing subsequence with both. So what it will do is, it's going to create, so okay, so add 1 to each of these, right? So 7 itself contributes 1, and the already increasing ones were like 2, right? So 2 and 2, and the max of this is also 2. So I update this to 2. Okay, next I move my pointer to this, sorry, and I see that once I read all the way to the right, this one is greater than 3. This is also greater than 3. This is also greater than 3. That means all 3 of these can create increasing subsequence, including 3. Okay, so what's going to be the length for them? So it's going to 1 plus 1. If 3 makes a subsequence with 18, then the new subsequence length is going to be of size 2. This is also 2, and this is 1 plus 2, 3, right? Okay, so that means the highest among these is 3. So I save this value 3 here. Okay, so now you see that basically what it says is, we have a subsequence from here and then from here, right? Something like this, which is of length. Then I move, which is of length 3. I move here, and then I read everything to the right. And as you can see, this is a potential one. Sorry, this is not, because this is smaller, but this is larger, this is larger, this is larger, right? So 5 can create increasing subsequence with 3 of these. And as you can see, if it creates one with 18, the new subsequence length is going to be 2. If it creates with 101, that's also going to be 2, and this is going to be 3. If it creates with 7, and it cannot create any increasing subsequence with this. Okay, so the highest value is 3, so that's it. Okay, next, this one can create increasing subsequence with this, this with everything. And as you can see, if I add 1 to each of these, the highest value is going to be 4, right? So this is 4. I move to this one. This one can create increasing subsequence with this one and this one. So as you can see, both of these are 1. So adding 1 more becomes 2, right? Okay. Finally, this 10 can make increasing subsequence with 101 and 18, right? Although I'm reading from here, I get these two, both of these becomes 1 plus 1, 2, and my highest one is 2. Okay, fine. And meanwhile, I am keeping somewhere, say, max sequence length. So every time one of these is calculated, it's I update the max sequence length, and as you can see, max sequence length is 4. Okay, so what's the complexity of this algorithm? So as you can see, this pointer, this one moves order of n times, right? Because I move from rear to the all the way to the front, and every time I read all the, like in the worst case, I read everything to the right, right? I read everything to the right to see if any of these values are bigger, larger than the current pointer value, right? The value at the current pointer. So that's also this one, this reading also takes order of n, right? So its overall time complexity is order of n into n. So the time complexity is order of n square. Okay. And now the space complexity, as you can see, we have this array to keep track of the longest subsequence length from starting from each index. And this is order of n. So space complexity is also order of n. Okay, so there goes our dynamic programming solution, the bottom-up dynamic programming solution for this problem, and this is an order of n square algorithm. Now there was a follow-up, and the follow-up says, can you come up with an algorithm that's order of n log n? Well, that's also a little bit tricky, but we'll discuss it in another video. But the solution that I showed you is a decent solution, so you can actually use this solution in the interviews. But the smarter one, we'll talk about this later in a later update of this video. Okay, so let's take a look at the code, and the code is super simple, just what I explained in the explanation. Initially, we have a memory array dp of size of the input, and then this integer max sequence will contain the maximum length sequence to keep track of the maximum length sequence. And then we are going to fill up this one with ones, because every element is a sequence of itself of length 1. And then we start this first pointer, we start from the last element, right? And then we go all the way back to the first element. So this is the outer for loop. Inside that, uh, for each ith index element, we will read from the next element up to the last element. And we'll keep checking if this ith element is smaller than this jth element, right? If that is the case, then you can say that the ith element creates a sequence, can create a sequence with jth element. So jth element has already its value calculated. So 1 is going to be added to it if ith index element creates a sequence with it. So we take the maximum of its current cache value at ith index, the sequence length, or 1 plus the sequence that is created from the jth element. We take the maximum and update the sequence length at ith element. So once everything is done here, then we are settling with the maximum sequence length that starts at index I. And then we check if that new calculated value is even greater than the max sequence that already we have got uh, up to this point. And if that is the case, then we update the max sequence. So finally, after checking every element, after I come out of this, the max sequence, this one will have the length of the maximum sequence, and then we return it. Thanks everyone for watching. We'll come back with another problem next time.